All right, hello. Welcome to our lesson on polar coordinates for our trigonometry class. This is going to be section 9.1. We're going to cover all things related to polar coordinates in this lesson. So the first thing to point out is in the red boxes, I have the formulas you're going to need for converting first from polar to rectangular and then from rectangular to polar. So what we're going to begin with is ordered pairs. Most of you are familiar with the ordered pair x comma y. That is a rectangular set of coordinates. In the polar coordinate system, we also have ordered pairs, but that's r and theta. So we have two different coordinate systems. We have the rectangular coordinate system, which is x comma y, and the polar coordinate system, which is r comma theta. And anytime you have more than one coordinate system, it's nice to be able to convert between the two. And so that's what these formulas are going to do for us. We're going to be able to convert back and forth between rectangular and polar. But before we do any converting, really the place to start is how do we plot points? I think most of you know how to plot a rectangular ordered pair. What we're going to focus on is plotting polar coordinates, okay? Plotting a polar ordered pair. And so if I could, let's get this out of the way, and we're going to look at an example. How do we plot polar points? We're going to start with this ordered pair. And just to let you know, if they don't tell you that this is a polar point, you're not going to know unless it has the degree symbol, and then you know for sure that that's a theta, that's an angle, and you'll know that that's a polar coordinate. But if there's no degree symbol, then this could be an xy or it could be an r and a theta. So they're going to tell us, hey, this is a polar point, and so we're going to know that this is r and theta, and the instructions here would say plot the polar point. And so to do that, the first thing you do is locate the direction, and then you're going to go in that direction or away from that direction. Okay, so our direction is pi over 2. That angle is positive. So pi over 2 is the same as 90 degrees. That is the direction we're going. And then the radius tells us how far in that direction to go. So since the radius is positive, we're going to go 1, 2, 3 spaces. We're going to go 3 units in the direction of pi over 2, and that's done. That point is plotted. Okay, so to make it rhyme here, you have to put the dot in the right spot. Put the dot in the right spot. Angle first, and then the radius. Let's do another example. Okay, let's take the ordered pair, -2, 3 pi over 4. So here again, they're going to tell us that this is a polar point. So this is an r and a theta. And the first thing you do is locate the direction. 3 pi over 4 is going to be the same as 135. Again, positive angles go counterclockwise, so that brings us around to 135. And then notice this time the radius is negative. So instead of going in the direction of 3 pi over 4, we're actually going to go in the opposite direction, in the direction of 315, 2 spaces. And that's going to put us right there, okay? So did you catch that? If the radius is negative, that says, hey, don't go in the indicated direction, go backwards, go in the opposite direction. And now that point is plotted, and that's done. And I think we should probably do at least a couple more examples just to make sure we cover all the bases. Okay, so let's next look at this ordered pair. Again, we're told that this is a polar point, so we know that this is an r and a theta. Notice that this time our angle is negative, and what that means, it means instead of going counterclockwise, we're going to start at 0 and go clockwise 2 pi over 3. So pi over 3 is 60. Okay, so here's negative 60, another negative 60 is going to be equivalent to going in the direction of 240. Okay, so here's our negative 2 pi over 3. That is the direction, and the radius is positive. So that says go in that direction 1, 2, 3, 4 spaces. And so that's where that point would fall. That's going to be in quadrant 3. In the direction of negative 2 pi over 3, we go 4 units in that direction, and that's done. All right, one more example. One more example. And let's do negative 1, negative pi over 3. So I don't know if you've been keeping track of what's going on here, but I've now done an example of all of the possible combinations of negative and positive radius and angles you're going to see, okay? Both positive, radius negative, angle negative, and now we're looking at both negative. Now we have a radius and an angle that are both negative. So what do we do first? We do the angle first. Negative pi over 3 is going to be in the same direction as 300 degrees. Remember, negative angles go clockwise. And our radius is negative, which says don't go in that direction, go opposite. And if you can see that right there is where that point's going to go in quadrant 2. Here, I'll delete it and make it a little bit smaller. Can you see that? That's 1 unit away from the direction of negative pi over 3. 1 unit in what really is the direction of 120, okay? And if you have any other questions or comments about plotting polar points, please leave those in the comment section below or text me. And that's going to do it for plotting points. Now, the next thing we're going to move on and look at is converting. And that's going to take us to this example right here. Next example, let's look at 3 pi over 2. And they're going to tell us polar coordinates are given. Polar coordinates are given. Find the rectangular coordinates. So here they give us an r and a theta. What they want is an x and a y. And that means we're going to need to use the formulas indicated above, okay? So if you made a note of those formulas while I had them displayed, x is r cosine theta, and y is r sine theta. And so if I do a little plug and play, x is going to be 3 cosine pi over 2, and y is going to be 3 sine pi over 2. And what better way to do that than with the calculator? So since our angles are radians, we are going to need to switch to radian mode. And then we can simply type in 3 cosine of pi over 2. And we get 0. So that means that our x coordinate is going to be 0. And if we bring the calculator up and go back, I can delete and choose sine instead. 3 sine pi over 2. That's going to give me a 3. And we're pretty much done. We just need to write this as an ordered pair. So here's what we've done. We now know that the polar point, 3 pi over 2, is equivalent to the rectangular point of 0 and 3. And that's done. And there is a way to check that. Okay, notice that I've got 2 different ordered pairs in different coordinate systems, but listen, they should plot in the same spot. If they don't plot in the same spot, then you screwed something up. So first, let's plot our rectangular point, 0 and 3, says to go up 3 units on the y-axis. Okay, so there's this point plotted. Now to plot the polar point, and we just covered how to plot polar points, so you should be somewhat knowledgeable of that at this point. No pun intended. Pi over 2 is 90, right? Okay, pun intended there. And the radius is positive, so that says to go 3 units in that direction, and that's going to plot in the same spot. And that means we have the right dot. Okay? Done. Now let's do another example of converting. Let's talk about this ordered pair. 6.3, 3.8. Now from the looks of it, this looks like an X and a Y, but they tell us polar coordinates are given. And that means that we have an R and a theta. Notice that the 3.8 does not have a degree symbol, and so that means that that is a radian angle. If they tell you polar coordinates are given, you know you've got R and theta. If there's a degree symbol, then you know that's degrees. If there's no degree symbol, then that means you've got radians. And so they ask us to convert to rectangular coordinates. So we're trying to find X and Y, which means we're going to use our formulas. Okay, so we know X is R cosine theta, and Y is R sine theta. And you are going to need the calculator for this. So here we go. We're already in radian mode. We're going to say 6.3 cosine of 3.8. And we're going to need to round that to the nearest hundredth. Now, in the instructions, they will have to specify where to round to. And in the instructions I'm looking at, it says round to 2 decimal places. That's the nearest hundredth, which is going to be negative 4.98. And then for the y coordinate, all we need to do is simply back up and delete cosine and insert sine. And that's also a negative value, negative 3.85. And to wrap it up, remember you need to write your answer as an ordered pair. So as an ordered pair, that's going to be negative 4.98, negative 3.85, and we're going to put a box around that because we're done. That is the answer, and I'm going to illustrate one more time. How do you check that? Remember, the points have to plot in the same spot. So let's do our rectangular first. We're going to go to negative x and negative y. 1, 2, 3, 4, 5. 1, 2, 3, 4. So that's almost to negative 5 and almost to negative 4. and that's going to be quadrant 3. Okay, so it's important to illustrate which quadrant it's in, because usually if you can get in the same quadrant, you're good. Okay, now to plot our polar point, we've got 3.8 radians. So remember right here, if we start at 0 degrees and come around, this would be 180 degrees, which is equivalent to pi, which is approximately 3.14. So 3.8 is going to be a little bit past 3.14. So that tells me that 3.8 radians should be a quadrant 3 angle because it's a little bit more than 3.14. And then the radius, since it's positive, says to go in that direction 6.3 units. 1, 2, 3, 4, 5, 6, and then some. A little bit more than 6. And I try to stay to scale, so that makes me feel pretty good about my answer. It looks like those points are going to plot in the same spot. And we're done with that. Now, if you're keeping track of what we've done, we just completed doing 2 examples of polar to rectangular. Guess what we're going to do next? You got it. We're going to do rectangular to polar. So for this example, they're going to tell us rectangular coordinates are given, find the polar coordinates. And since they tell us rectangular coordinates are given, that means that we have an x and a y. We're looking for r and theta. And again, if you made a note of the formulas that I had listed before, remember that r is the square root of x squared plus y squared, and theta is the inverse tangent of y over x. And all we need to do now is plug and play. So we're going to have the square root of 1 squared plus negative 1 squared. Please remember that these parentheses are necessary. And that's going to work out to be the square root of 2, which is the exact value. So I'm going to leave that in radical form instead of giving a decimal approximation. Square root of 2, that's my radius. Now for my angle, that's going to be the inverse tangent of y over x, which if I simplify that, that's the inverse tangent of negative 1. And I should be able to bring up the calculator and do the inverse tangent of negative 1. And since I'm in radian mode, I'm going to get a radian angle, negative pi over 4. Negative pi over 4. All right, so let's look at what we've got here. We now have our polar coordinate, r comma theta, would be square root of 2, negative pi over 4. Let's play the what if game, though. What if they wanted a positive angle? What if they wanted the angle to be positive? Well, we know that negative angles go clockwise, and negative pi over 4 would be 45 degrees into quadrant 4. So what would be the positive equivalent to that? That would be 7 pi over 4 is the positive equivalent to negative pi over 4. So another correct answer could be square root of 2, 7 pi over 4. And if you think about it, those are both correct because they will plot in the same spot. Since the radius is positive, square root of 2 is about 1.4. That's going to be about 1.4 units into quadrant 4. in the direction of negative pi over 4, which is equivalent to 7 pi over 4. Now, there are a couple of other correct answers. Let me show you that before I move on to the next example. Another correct example could be negative square root of 2, 3 pi over 4. Think about that for a second. Where is 3 pi over 4? That's in quadrant 2. But since the radius is negative, that says go away from that direction. Okay, so since the radius is negative, that tells us to go in the opposite direction of 3 pi over 4, which would still plot in the same spot. So this is also correct. Okay, and there's probably, you know what? There's an infinite number of correct answers. An infinite number of correct answers, because you can always make a complete circle and get a new angle and still go in the opposite direction. And that goes for the positive radius also. You can, if you're starting in this spot, you can go a full circle, which would be a different angle and would plot in the same spot. Which, I don't know if you noticed, that's kind of cool, that there's only one way to represent an ordered pair in rectangular form, but there's an infinite number of ways to represent an ordered pair in polar form. Kind of cool. Okay, I'll step off my preacher's box there, and let's go on to another example. We need to look at least one more example of rectangular to polar, and that's going to be this example. At least one more. We may look at one more just for fun. Okay, so let's consider this ordered pair. Here they tell us rectangular coordinates are given. Rectangular means we're given an x and a y. It says find polar coordinates. So we're looking for r and theta. And so if I do a little plug and play, that's going to be the square root of 5 squared plus 5 square root of 3 squared. And that's going to be, well, let's see, 5 squared is 25. And since here I've got two separate factors, each one of those is going to get squared. That's going to be 25 times 3, because the square and the square root cancel, gives me a 3. And what is that going to be? 25 and 75 is 100. Oh, cool. So our radius is going to be 10. And our angle is going to be the inverse tangent of y over x. And those 5's will cancel, which will simplify to the inverse tangent of positive square root of 3. And that we can get from the calculator. The inverse tangent of square root of 3. Positive pi over 3. All right, and now we've got our r and theta, and notice our angle is positive, so we're happy with that. We're pretty much done. So our ordered pair in polar coordinates r comma theta is going to be 10 and pi over 3. Hey, and don't forget about checking to make sure you feel good about your answer by plotting the points. A positive x and a positive y would be in quadrant 1. And pi over 3 is also a quadrant 1 angle, and the radius is positive. So we feel good about that answer. Both of these points will plot in the same spot, okay? That makes us feel good about our answer. And then that makes me feel bad about not doing another example. So I need to warn you about something that will happen. Let's see, one more example so that I can warn you about something. Let's consider this ordered pair. Here they're going to say rectangular coordinates are given, find the polar coordinates. So here an x and a y is given. We're looking for r and theta. Okay, no big deal. We've done this twice already. But there's something different about this point that at the end you need to consider. All right, so here we go. Doing a little plug and play. For the radius, that's going to be -3 squared plus 3 squared. Remember that these parentheses are necessary. 3 squared is 9, and 9 is 18. And the square root of 18 in simplest radical form is going to be 3 square root of 2. If you need help with that, use the calculator. More often than not, they are going to want this answer to be exact, not a decimal approximation. So let's leave that as 3 square root of 2. And then for our angle, theta, that's going to be the inverse tangent of y over x. And that will simplify to the inverse tangent of -1, which we've already done that one time. Right up here, remember the inverse tangent of -1? We got negative pi over 4. And this is where I need to bring your attention to something that you have to focus on, okay? Did you notice that our x is negative? Okay, anytime x is negative, you're going to have to add 180 to theta. In order to get the right angle, if x is negative, you have to add 180 to theta. And I'm saying 180, that's degrees. Pi is equivalent to 180. So in this case, we're going to have to add pi to get the correct angle. Let me illustrate why that is. Remember I said that the points have to plot in the same spot. So if we plot our rectangular coordinate, -3 and 3 is going to plot in quadrant 2. But if I plot the polar coordinate, if I leave it negative pi over 4, negative pi over 4 is in quadrant 4, where the radius is positive, and so that would say go in that direction, whatever 3 square root of 2 is. It's going to be a little bit more than 3. Can you see that these points are 180 degrees out of phase? And that is why you have to add 180 to theta. That's so that your point will plot in the same spot. Then you'll have the correct dot. So what is our actual answer going to be? Our correct answer, we're going to have a positive radius, and our angle is going to be 3 pi over 4. Negative pi over 4 plus pi is 3 pi over 4. Now remember I said there is another way to express that. There's always going to be multiple correct answers for your polar coordinate, okay? So instead of adding 180 to theta, we could have just made the radius negative. So we could have said -3 square root of 2 and kept the angle the same. This is also correct. And again, if I could illustrate why, negative angles go clockwise, and negative radius says to go opposite direction. So if we keep the negative pi over 4 and make the radius negative, that'll make us go in the opposite direction, and we'll plot in the correct spot. Okay, I hope some of this is making sense. I hope all of it's making sense. Remember, if you have any questions or comments, you can leave those in the comment section below, or you can text me. And now we're going to look at the last examples that we're going to do before we shut this video down. We do need to look at converting equations from polar to rectangular and vice versa. So here we have an equation. We know that this is in rectangular form because it's got x and y's. Here, the instructions would say, convert this equation to polar form. So what they're going to want us to do is they don't want any x's and y's. Instead, they want r's and thetas. And so that's where the formulas are going to come in handy that you need to know. X is r cosine theta, and y is r sine theta. Those are important. Memorize those. Make a cheat sheet. Get a tattoo. Whatever you need to do to remember those formulas. Here we can replace x with r cosine theta, and we can replace y with r sine theta. And so that's going to give me r cosine theta quantity squared equals 4 r sine theta. Do you see what I did there? I replaced x with what x is. X is r cosine theta. And I replaced y with what y is. Y is r sine theta. And then we can simplify this a bit. Not that you really need to, but we are going to simplify this at least one step. Notice that these are two separate factors, the r and the cosine theta. And if you're squaring multiple factors, each factor gets squared. So that'll be r squared cosine squared theta equals 4r sine theta. And I'm going to call that good because that is now technically in polar form. There's no more x's or y's. Technically, we're done. And we're also going to look at an example of going the other direction. Let's take this equation. R equals cosine theta. So here we know that this is a polar equation because we have r's and thetas. The instructions would say convert to rectangular form. And so here are the formulas you need to know. R is the square root of x squared plus y squared. And, well, actually, the formula we're going to use here is x equals r cosine theta. But the other one that you need to keep on the back burner, or that you need to know, is theta is the inverse tangent of y over x. So make sure that you have these memorized or on your cheat sheet or get a tattoo, whatever you need to do to remember those. But for this particular problem, we're going to be making use of this formula and this formula. Now, notice that this equation only has cosine theta. It's missing the r that we would need to replace that with x. So what I'm going to do is I'm going to multiply this side by r so that that becomes r cosine theta. And I know that r cosine theta can be replaced with x. But remember, whatever I do to one side, I have to do to the other. So I'm going to, in a sense, I'm going to multiply both sides by r. And that's going to give me r squared equals r cosine theta. So now what do I know? I know that r cosine theta is x. So I can replace that with x. But what is r squared? Okay, so let's come to this formula and let's square both sides. So that's going to say r squared is, a square and a square root cancel, x squared plus y squared. And so what does this tell me? This tells me that anytime I see an r squared, I can replace it with x squared plus y squared. And so that's what I'm going to do. X squared plus y squared in place of r squared. And then if I wanted to simplify this, I could set it equal to 0 by bringing this x over, would make that minus x equal to 0. Sometimes they want you to set it equal to 0. But there's the equation converted from polar to rectangular. And I know I'm done because there's no more r's and thetas. It's all x and y. And that's where we're going to end this lesson. I've covered, I think, everything you're going to need to see in order to be successful in this section, okay? So if you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.